So just to recap, AllJoyn is an open source framework really to provide the glue for the Internet of Everything. It's a way to publish a set of APIs that you create or that is become standardized through the AllSeen Alliance. And it's really about finding ways to find things around you that are interesting and expose those types of APIs at a service level so that you can find out, oh, this is a device that supports maybe temperature, and I can see those readings from my device that has no knowledge about temperature or how to access that. Maybe it's about providing ways on how to link up things at a finer level, so when maybe you open your door, your lights blink. And all these things can now start to happen because everything speaks a common framework, and they speak these different API sets that are both discoverable. They run over different radio links, they run over different transports, and they run across various different operating systems. So AllJoyn is designed as a distributed bus architecture. It's really, again, that glue on how things are going to connect. And what happens at the lower level is AllJoyn messages are passing back and forth, these datagrams that contain information as far as who the sender is, where the destination is going, so what's the endpoint, what's the signature of the payload, what is the method and specific API that's being interacted with, and what's the data that goes along with that. And so all these things happen ad hoc. So you don't have to have a certain startup order or anything. You can just discover, devices can leave proximity and then come back into it. And regardless of the transport, it allows everything to kind of run together. So you could have a device that's connected up over Bluetooth to a multi-mode device that supports, say, Bluetooth and Wi-Fi, and then that can interact and you can bridge the communication across this all. So looking at things and kind of elaborating on that point, at the highest level, looking down on AllJoyn, we're actually building a graph. And so we have what's really the routing node, and I'll start to explain this in the following slides, and leaf nodes that connect up just to routing nodes. And routing nodes would connect up to other routing nodes. And so you can start to form this mesh and create this graph of interaction. And all of these different endpoints here are completely addressable and can interact. So one leaf node on the far left here of the screen can interact with any of the leaf nodes all the way over on the right. And the message is, what happens at the routing side is it's going to look at those messages as they come across, and it's going to see the destination, and it's going to see if there's any leaf nodes or applications that it can pass the message to. And if not, it passes it down the pipeline. And so all these things start to interact and communicate. So this happens through a couple things at a high level, and we're really going to focus in on the discovery side today on how you advertise and make yourself known and how you establish that connection, because this is a fundamental piece on creating from a leaf node to connect to a routing node, and for applications at the traditional sense of AllJoyn to be able to communicate with each other. So one side is going to say, I support these interfaces. Maybe it's AllSeen Media Audio, and it's going to publish that through an advertisement. And the other side says, hey, I'm interested in that service, and so it's going to find that, and AllJoyn makes it quite simple, and it's going to form a connection. And once that happens, a session is created. You can conceptually think of a session as a grouping, right? It's a way to group interactions that you're curious with. And so once that happens, you have this session, and we'll dive in deep into what you do once you have a session in the second training next week. But you can start to interact. You can execute RPC method calls. You can send signals that will interact with all of the devices around you that are on the session, so you can uniquely address each individual piece or the group as a whole. And it allows for efficiency, too, of all the communications, and for the focus to be on the application side, on maintaining a clean set of APIs that are published, on the actual user-level interactions and the functional interactions, as opposed to needing to worry about how do I send a UDP packet, how do I maintain a TCP connection, what are the headers on a keep alive, all these difficult things, and then what happens with this new radio transport, right? At its highest level, AllJoyn takes that all and just abstracts it away from needing to be as a burden on you as a developer. So looking at the model at a high level, AllJoyn kind of sits on the network stack at about 3.5, 4. So you can see here we have all of the, on an IP stack, we can have run over Wi-Fi, Powerline, Ethernet, Wi-Fi Direct even. We have the framework. And again, today we're going to focus on the left box, the discovery side, and really also the advertising side, and on the connection management. How do you actually form a session and have awareness of what's happening on that? And just to give you some background, all of this information that you're receiving today is actually included in some of the building blocks of these base service frameworks. So onboarding takes advantage of advertising and the concepts of that we're discussing today. Control panel takes advantage of having a session and being able to dynamically execute API methods. And the same thing is true for notifications, where it's a publication across to all the devices to be able to receive a human-readable string. And so from today, you'll be able to go and analyze these services, look through the software, possibly even take them and write your own service framework, or just use AllJoyn in its classic sense for maybe building a game like checkers or chess or something of that nature, a board game, and using this information to start to build your application to discover and connect up in the more classical sense as opposed to IOE type of use cases, IOE, Internet of Everything. So from the software components, we really have a client library, and it's broken into two parts. We have the standard client, which is primarily running on a high-level operating system, so like on Android, on iOS, on your Linux machine, your Windows desktop, any of these types of environments that have threading environments and that have multiple ways to program onto the language. So there's multiple language bindings. AllJoyn itself is natively written in C++, but it's extensible so that on Android you could write an application in Dalvik. Or on maybe your Windows desktop, you choose to write something in JavaScript for your web browser. So you have all this ability to leverage on whatever programming environment that you're comfortable with for the language bindings that were supported. You get to choose your flavor of how you want to use AllJoyn and take advantage of the APIs to publish and communicate with things around you. And then we have the thin client version. And the thin client version is really that leaf node piece. And in essence, an application is kind of a leaf node as well because it can't route messages itself. But as a thin client, we've taken out the ability to pass messages on, and it's implemented in C, and it's really designed for memory-constrained devices running MCUs that have very small RAM and ROM footprints. And there is a requirement, if you remember from a couple slides back, that a thin client must connect to a routing node. And that routing node is embedded in the build of a standard client. And so looking at that a little bit more here on the routing side, every application that takes advantage of AllJoyn on a high-level OS has two ways that it can include the ability to be deployed. On a Linux environment, you can either have a single routing node running as a daemon process, or it can be part of an application that's downloaded. So if you had on an Android device or an iOS device 5 AllJoyn applications, well, there would actually be 5 routing node instances on that device, assuming that they're all running at the same time. But maybe on a Linux environment such as something running OpenWRT, you'd be able to have just one routing node, but you could have many applications leveraging that piece to pass messages over AllJoyn to all the other devices. So the architecture yields for both cases, and it's really designed to fit the one daemon model, but it can extend for more as it's a less optimal solution. So the main parts of the routing nodes, as I've been talking about, is really about managing the distributed bus architecture. So being able to deliver the messages to those leaf points or to an application that's using the AllJoyn APIs. And as such, it enables cross-device communication. It can route across different wireless transports, and you really think about it as the routing node does the heavy lifting of an AllJoyn system. And the leaf nodes must use these in order to be functional across the environment. If I had a leaf node that publishes notifications and there's no app around to listen to those notifications, it doesn't really make a sound because there's no endpoint, right? There's no functionality on the other side that can take advantage of the APIs that are being leveraged on this leaf device. So looking at how this works in a practical sense, I'll just run through these images here. So we have an application that's on my device, or potentially this is a routing node, and I have thin client devices that want to connect to it. So it's going to advertise a name. On the other sides here, this application B is going to discover it and find that A is nearby, and C is going to find that A is nearby. So that's a very simple process, and depending on the different transports, it can be a really tough problem. One of these devices could be over Wi-Fi, some could be over Bluetooth, and how do you bridge that? How do you get your mind as a developer around, I need to be an expert in all of these different pieces? So once you find something that you're interested in, you're going to want to connect. And so you're going to be doing a join session to be able to start to establish this communication. And this can happen both under the hood. If these were thin client devices, the leaf nodes, they would just connect to the routing node automatically. But it's important to understand that, again, at its core, whether you're a leaf node, a routing node, whether you're using AllJoyn at an application, all of these three fundamentals that we're talking about, advertising, discovery, and joining of sessions, are all parts of each of those processes. So once we've tried to join, the other side will reply back with an acceptance, so true, and then we're all in a peer session. Now, there is a line from B to C, and B has an awareness that C is on the network and it can communicate with it. And everything at this point are all peers. Even though B joined A, B can address C can address B, and they can all communicate together. If these were leaf nodes, then the traffic would A to get between the B device, but it doesn't stop. So the traditional flow that I take, and one that I talk through when I work through with a customer on how to use AllJoyn or try to talk a developer through this, is the very first thing that you do is you're going to connect to AllJoyn. You're going to connect to the bus. And then you're going to think in your mind as you walk through your code, you're going to want to establish how you want to communicate. Is it going to be over Wi-Fi? Is it going to be over Ethernet from my device? Is it going to be over Wi-Fi Direct, maybe Bluetooth? How do I want to choose this, and how do I want things to communicate with me? Is it going to be, and I'll explain what this means later on today, a multi-point session or a single point session, so a one-to-one or a one-to-many? And then you go through and after you decide that, you choose your unique identifier, so what you're going to let others know to be able to understand who you are. And now you're going to turn the corner here and you have two options. Now these can run in parallel and you can do both, or you can be one side. And you're either going to create a group, right? You're going to create a session. And so really think of it as a way of addressing and grouping the applications around you. Or you're going to find a group that you're interested in, and then you're going to start to advertise and tell everyone that you're here and you're ready to be interacted with. And then you'll get into what we'll cover next week, which is really about what do you do once you connect and communicate, right? Are you just going to be a game and broadcast player position, or are you going to be maybe computing mathematical equations and physics models and need to exchange information, or maybe you just want to tell a device to turn on? So all those things, that communication layer, really is kind of the last piece. Once you've connected, you can do anything. AllJoyn has that flexibility. So coming into more of the SDK concepts a little bit more, AllJoyn exposes all the functionality through an interface that an object implements. And these objects have hierarchies associated to them, and they can implement more than one. right? So you can have, as you saw earlier, there was an org AllSeen Media audio and an org AllSeen Media video, right? There could be an org AllSeen control panel, an org AllSeen notification. All of these different interfaces can all be implemented by one object or can be split out between a bunch of different few. It's up to you as a developer to decide where you want these interfaces to live in your thought process. It's very much object-oriented programming. And all these interfaces, when you build them out, they're going to be methods, but they have different semantic meaning. There's an actual method name, which is more like a remote procedure call, an RPC. There's a signal, which is an asynchronous broadcast. And there's properties, which are really get and set methods so that you can access a variable, just as if you would if you were defining a class and building out kind of private variables and public variables and your public methods and your private methods. As you go about your object-oriented approach, you can directly apply that now in a distributed model. And the big important thing here is that you can build an application, use an AllJoyn interface. Someone else can go build a completely separate application with an absolute different functionality. And you'll be able to then discover through a process called introspection, and you can ask the other device, what interfaces do you have? What do those methods look like? How can I call those methods? And then you can dynamically start to execute and be able to interact with this thing that you've never seen before. It's one of the real big powers and something that next week we're really going to dive into, because it's a tough thing to get your head around, right? I found this thing that's interesting, I connected to it, and now I can just start placing API calls without having any prior knowledge. It's going to once you start using it, it just makes things so wonderful and simple. So looking at a diagram here to kind of wrap your head around the object model, and we'll really focus on this. So if you have questions on this, please attend next week. Again, today is really focused on finding that interesting object you want and connecting to it and setting up all the pieces to interact. So we have here kind of two applications. The side on the left is really more of the service side, and the side on the right that has the proxy object and the signal handler, that's really kind of more the client side in this type of application model. Now again, they can switch roles and they can both be clients and servers at the same time. But what this is showing is that you can start to execute from one side, and all the methods will flow over the AllJoyn distributed bus. And it really is a way of blending and combining the two applications to be one. So you're almost adding a library on another device into your application. So this leads us more into some of the technical details here on what exactly is happening. And a well-known name is a very important piece to know, because the routing nodes advertise a well-known name. They advertise that they are a routing node via org AllJoyn routing node dot and a random value. And your application that you write could use a well-known name, or it could use the service level discovery that we'll go into. So the well-known name really is about providing information so that you have a way to quantify and understand from the many AllJoyn applications around me what actually is important. What is it that I can understand so that I can find my game that I wrote between the 20 other different AllJoyn applications that are here? How do I even know that my game is being run by somebody else's on someone else's device here in my proximal network? And so we do this by creating the well-known name, and it follows a normal naming convention of reverse DNF naming, so org AllSeen training. And this has a structure to it that's up to 255 characters. It must use an alphanumeric or a dot and a period, and when you ask AllJoyn to hold on to the name so that it's associated with your endpoint, it has to follow the convention where there must be at least one period, and after any period in the name, a number cannot follow. So this leads us to the next thing, that every name needs to be unique. If I say I am org Brian, and some other application says it's org Brian, well then it's difficult to figure out what exactly is that, right? I don't understand that because I see two things that look the same. And so if we look at that, both of these two applications say I'm org AllSeen Training, right? They've advertised that well-known name. Application 3 comes along and it says, what do I connect with? AllJoyn's going to tell me about both instances, but I can't uniquely address either one of them because I can't figure out how to route that and display it to my end user, right? It just doesn't make sense. I know there's two separate apps, but it looks like it's just one. So we can get away from that pretty easily by just appending a random value to the end of the string. So now I see I'm org AllJoyn Training, right, with 1, 2, 3, 4. I see the other one with 9, 8, 7, 6, and now I know and I can determine both. So looking at some examples here, we can see there's some good names and some bad names. And the reason that that one popped up as bad is because a number followed the dot. And then we have the last two, which are quite long, but they're really kind of the best names. And this is because it takes a combination of a few things. One, Brian on the end of that one that's there, that's something that we could parse off as a valuable piece of information. We can maybe display that in the UI. So that I know that this, if I'm playing a game, for instance, I know that Brian is nearby, right? And maybe Brian's my friend, and I can tell him, hey, Brian, do you want to play a game? But it also has that long random value there, and that really allows for uniqueness so there's no collisions that occur. And it's easy to add that. You just use the API call to get the global GUID string and just append that right onto your string. So well-known names, what they mean to AllJoyn is a mapping to what's called the unique name. Now the unique name is what's assigned to any leaf node or any application that's connected to a routing node that's using the AllJoyn APIs. And it gets assigned when you use a call to connect to the AllJoyn bus. And it is normally it's a semicolon followed by 8 alphanumerics, and then a period, and then a short. And that short value will actually increase over time depending on the different functionality and interactions that you're using with AllJoyn. So if you're sending a lot of what we call sessionless signals, then that number will be increasing because you're creating new temporary endpoints. And so you can see there's some examples there. And so using the API calls, knowing this now, when you start to discover things, you'll be able to leverage AllJoyn to either use the well-known name, so the full name that you found, or when I talk through about the About feature here on the next couple slides, I can use the actual unique name that I found out from the About signal to be able to call APIs and start to introspect and query the device on the other side to find out how to interact and to directly address that application. So the unique names internally, they map to and build a table of an IP address, say over Wi-Fi or IP transports, or if it was over Bluetooth, it would be the Bluetooth address and how to set up that connection. So it maintains that whole table on how do I connect to this thing on the other side. So when a leaf node or an application asks to connect, I can form that connection for them. And it also helps save power at that time because we aren't always forming connections with everything, right? We're allowing the user to say, here is some information that will help you to determine if you need to connect or not. So now that you have your well-known name, you're going to publish it for all the other AllJoyn applications out there, and that's through a process called advertising. And so what happens with this is that well-known name gets bundled in, and it gets sent from a routing node, right? When the routing node is either part of the application or a process by itself. And what it's going to do is send that out as a UDP broadcast on a port that is registered for the AllJoyn project on 9956. And the message name is called isAt. So if anyone looks at any of the network traffic as they're running AllJoyn applications, you'll see this isAt message. and it contains a list of all the addressable endpoints and any well-known names that are associated to it. And so if you're really curious and want to look at this and see what we're doing in the source code, you can go into the AllJoyn core project, and you can pull that down from the AllSeen Alliance Git repository. And inside AllJoyn core, there's the router software, and that's that routing node software. And inside that, you'll see the namespace, NS, and that has all the code in there that handles sending out these multicast packets and creating the mapping of the well-known names and the unique names to be able to identify things. So the typical flow as a developer, whether you're building a service or you're building an application, you're making use of the AllJoyn APIs. You first create your bus attachment. You call that connect method. You ask AllJoyn to hold on to your well-known name. And then you set up your objects that you want to have your APIs exposed. You set up your listeners, right? This is in a high-level OS, so you have some various callbacks you can take advantage of. And then you call a method to simply advertise. And that's going to do all the low-level work on IP transports of sending that UDP broadcast. On Bluetooth, it would use EIR and STP queries, so for some pre-associated discovery, it would temporarily connect and exchange that information. So all that stuff, the difficult part of sending out and letting others really know that you're there, that's all handled for you. So the other piece is around service level discovery. And we call this the About feature, and it's part of the AllJoyn core software. So this allows for the ability, instead of using that well-known name, something that you already have knowledge of when you build your app. So I'm building a device that's going to do all these magical things. But I want you, everyone here on the call, to be able to write an application to interact with it. And so I'm going to publish my interfaces, and I'm going to use the About feature to publish in an AllJoyn session with Signal the ability to tell you what this is, so you'll know that this is the make, the model, the manufacturer, and specifically you'll get to understand the interface list. So you'll know that I support org AllJoyn control panel, and maybe I support org AllSeen media, and I support all of these other interfaces that I've published, so that now your applications that you write, you'll be able to find my device that I created and just start to be able to interact with it. Right? I can go make this in a closed environment. I'll tell you the interface. You'll discover those interfaces, form connections, and then start to do something really, really neat. So part of the service level discovery, there's a spec that's been written for the About feature. You can go and look at that document on the AllSeen Alliance. You can go to the Git repository. You can pull down the service itself, or if you pull down the AllJoyn project, it's embedded inside of it. And it's the same flow, only now we don't request a name. What we do is advertise our unique name. So this is one exception here on the advertise name piece, where we can have AllJoyn take this, our local unique name, and without having to have a connection formed between the routing nodes, we can push that off our device over onto everyone else so that they're aware that we exist. So that when they receive all my interfaces from the device through the About feature, they'll be able to connect back up. And that's a big important piece is knowing when to connect, and once you've established that connection, you'll start to execute the RPC calls and send signals and actually leverage those interfaces. So we've gone ahead, we've created a name, we know what we are, we've published what our capabilities are, but how do we find that out? And that's all through a process that's built into AllJoyn called discovery. And so with that, what we're doing is we're asking the routing node to collect all those UDP is-at packets and send them up to us, and let us know if anything matches a prefix that we're interested in. So this is on the well-known name discovery. So when I know I write a game that's my com game Brian, and I know on the other side, if I want to interact with other players, I'm going to look for com game Brian. And so what happens is the routing node that's part of my app or on the platform is going to take those is-at messages, and first it's going to send a who has. That who has goes out one time so that we can immediately get is-at responses. But all those is-ats, if we've missed anything or a new device comes into the network, those is-ats are going to be published every 120 seconds. So in 2 minutes, we'll get another wave of is-ats, and we can take action and pass that up and actually tell the application, here's something that's interesting that you're looking for specifically. Would you like to do any actions with this device? So the typical flow, again, everything starts with creating a bus attachment. I hope you've seen that as we've gone through. Then you set up your bus objects. You set up your listeners. Those are all the common pieces that you will always do with an AllJoyn application. The next piece, you'll make an API call to start to find the name based on the prefix. And what this is going to do is set up, in your listener class, two different mechanisms here on your bus listener. You'll have, there's, I believe, 7 callbacks that are there, but the two that I want to highlight are the found advertised name and the lost advertised name. And this gives you the information. Here is the service that you're looking for. This is the prefix that was used to match it. And here is the transport that they're asking that it was discovered on. So I would find out, I found this interesting piece over Bluetooth, or I found this over Wi-Fi, or I found it over local communication because there's another app on the device. So each of these different pieces will give you all the information you need to then tell AllJoyn to start to connect. So in the found advertised name, one of the important things here on both found advertised and lost advertised is that it's a hint that something exists. It's not a guarantee. So if an application ends up publishing a found advertised name, you won't know until you connect up to it that it's actually present. So it's an important piece to understand as far as when you build a game or you build anything, and even on the leaf node side, because it could try to connect up, but then fail due to it could fail due to maybe that device walking out of the network right when it tries to connect. So the other piece of discovery is, again, using that about feature. And with that, you have the ability to again, find all those interfaces that you're interested in. Now, once that's happened, you're able to then join and connect just as if you were, as if it was a WellKnown name, but there's one caveat. With a WellKnown name, you get the understanding that something has left the network, but using the about feature, there's no lost direct information. So if I see 5 applications or devices that are using the about feature, maybe there's a bunch of TVs, and I walk away from proximity, where proximity is defined by being on the same Wi-Fi network, then I wouldn't get any information that they've gone away. And we have to use some other pieces of AllJoyn in order to understand that that's occurred. So just using the about feature by itself only gets you to the discovery side of things. It doesn't let you know that they've gone away. So again, the traditional flow is setting up the AllJoyn bus attachment, building, setting up your bus objects, your listeners, and then setting up the about feature to start to listen for things. And really, it's just setting a callback as part of the API. So now on to the next stage. If we're a thin client or we're an application, what we've now done is we've figured out, I've found something that I can connect to, right? It's interesting. Or you've published that you can accept connections. And now what we're going to do is we're going to create a session. And conceptually, this is really a way to group applications together that want to interact in an efficient way. And so what happens is any application here of the 4 that I have below can call the method of bind session. And what's going to happen is those advertisements are then sent out, and that lets everybody know that a connection, if you're interested, can occur. And there's a concept in a session that we call multi-point. And what that allows for is the ability to have one value for an ID such that now applications are grouped where if one leaves, every device knows that that application left. Or if a new application joins in, every device is now aware that it's part of the system, right? So it's a flag that you can set when you set up the API call, and it's important to understand this so when you architect your application, you design things correctly, right? Whether it's an application or a service framework that you're building, you really need to keep in mind whether you want to have a one-to-one connection or a one-to-many. And so you can see here, if application 2 set up a one-to-one, then application 1 and 2 would be able to connect. When 3 would connect to 2, there would be a separate session. But maybe there was a multi-point session, now everybody is grouped together. So all of these things here, what gets associated with a session is a unique ID. And that ID is passed into the different API calls so that you can address a group or a specific instance of an application. So in this case, if I use the session ID from C, I could send a message that would travel to the other 3 applications in the system. Or we could directly access one of the devices and have them execute some piece of software for us. So in creating a session, just looking at the APIs, one of the values that confuses developers is the port. We have in AllJoyn what's called a session port. And the session port has no correlation to any TCP port or any IP port on the system. It's just a value that can be used for you as a developer to help maintain your own flow of software interactions. So maybe you are creating a chat application and you want all your public chat messages or your session for public communication to occur and have that happen on say port 1, right? But then all your other logic for maybe private chats, you want to move those to a separate ID. You have the ability to kind of use the concepts of AllJoyn to design that framework. And the next piece on a session is the session port listener. And this is what allows any AllJoyn application the ability to grant or deny an incoming connection. So the typical flow is, again, you set up everything with AllJoyn and you either advertise using the About feature, sorry about that, or a well-known name. So looking at that session port listener in a little bit more detail, this allows you to, on the accept session join or callback, deny or accept. And so what that means is if someone's trying to connect, you'll understand the port value, so what your application logic has designed, who the actual other side is, and what the options they're trying to connect on, right? And one of the important things is if a device is trying to connect up over Bluetooth and you don't support Bluetooth, the AllJoyn framework will actually stop that at a lower level. So when it happens up here at this layer, you'll know, hey, this application, I support both Bluetooth and Wi-Fi, but you know what, I want to use Wi-Fi, so you'll set that value and it will return back to the other side and an IP connection will be made as opposed to a Bluetooth connection. The other thing that's important is inside this callback and inside any AllJoyn callback, you cannot block. Otherwise, timeouts will occur. Again, this is a distributed bus architecture. So if you need to do anything that requires blocking, you'll have to thread that on your environment, or in the thin client architecture where it's all in C, you'll have to design your software in a way that it won't take up much time and you'll be able to pass back a reply of either true or false, which would be a rejection or acceptance of a session. The next callback that you would receive is immediately following a true. You will receive back an ID through the session join to let you know that the other side is now fully connected and you've established a link between them. In order to join a session, on the flip side here for this API, I'll go a little quick because I think we can all look at the documentation on this. You'll just call JointSession, and you'll pass in what we talked through earlier, which is the well-known name or the unique name. And in doing so, it will go ahead and set up that whole process here of connecting. We'll see it in an image on the next slide. Sorry, let me do these out of order here. So the series of events that will happen, again, is we've gone through, we've advertised our service. It's been discovered on the other side. Connection has then been made, a determination in some UI or based on application logic. The callback for the accept session joiner has issued. True is being returned because we're going to grant access to this application. A response is returned of OK. The session joined is established. And now we have a session ID, and these two applications are now connected all through the AllJoyn routing nodes, right? That's that piece down there at the bottom. And now we can execute the entire functionality. Now this process right here occurs automatically when using the thin client software. So this is why conceptually these three components, the advertising, the discovery, and the connection are so important, because the embedded piece of software on a thin client will go ahead and find any routing node and use these three concepts to form a connection to that device that it discovered. And then it can go into low power and it can wake up and start asking the routing node for messages. So it really yields well for a nice topology and a framework at which all of these other parts of AllJoyn are built around and on top of. So I'm going to back up one slide. I'll let somebody mute here. Just to explain the session listeners, once we've established a connection, and sorry, these slides should have been switched, I apologize. What you'll want to do is be able to monitor that on both sides, both the side that created the session and the one that joined, so that you can understand when applications come and go. So there's in the session listener, there are the three callbacks. There's the session lost, session member added, and session member removed. And they do exactly what they mean. Session lost will let us know within 40 seconds when the TCP connection has been disconnected. The member added and removed will let us know when other devices come onto the system. So in that image at the very top, back in the beginning of my slides, this session member added would be executed when device B or C joined onto the network so that the other could understand that it's there and it could interact with it. And so the other piece too is if a device leaves the system, you'll get all that callback information. So this will give you all the information that you need to be able to update your UI elements in your app, right? To be able to make changes, to be able to reconnect to different pieces, and it gives you the flexibility to use an object-oriented approach and the model in AllJoyn to be able to form all these connections. So this leads me to the next thing, and this is the last piece to go over, and then I'll start answering some questions, and I'm sure there are some. I haven't seen the chat window yet. But with all this stuff, once we've connected, in order to perform something interesting and be able to interact, we use what's called a bus object. Now this is an encapsulation of all the interfaces that can be interacted with, such that it makes up your local set of APIs. So if this was a television, it might expose the ability to turn it on, off, right? Some power interfaces, right? Maybe to put it in standby mode. It may also support some controls, changing the channel up and down. And so each of these can be on different objects. There could be a /control. There can be a /power. Or however the developer chooses to build this out, right? It doesn't matter from an AllJoyn standpoint, nor really from a developer standpoint, because you're discovering the interfaces and that correlates to these different bus objects. And that's, again, using all the components that we've talked about today, as far as using the about feature, using your, discovering based on a well-known name, and then forming a connection and being able to interact with these different bus objects. Now, method calls are remote procedure calls, and you leverage those through what we call a proxy object, right? It's a local representation of something on the other side, because, again, it's a distributed architecture. And so with these, there's a reply that's invoked, and next week we're really going to dive into how you build out these interfaces and how you start to use these API calls. Signals are similar to methods, except for they are one-to-many. So a signal would invoke and execute on every application or leaf node that has been connected on the session. And we have a concept that's very powerful, and it's called a sessionless signal. And what this allows for is a broadcast of data, and under the hood inside of the routing node of AllJoyn, it's going to use a sessionless object, and it's in the routing software. If you look in AllJoyn core routing, you'll see a sessionless obj.cc. And that's a mini AllJoyn app in itself that rolls up the advertising, the discovery, the joining of a session in order to transmit these messages and the data that you want to many devices without having them specifically look for an interface or look for a well-known name. So it's a shortcut to do all the connection stuff that we've really talked about today. And so just again, using all these different interfaces and objects, it really takes an object-oriented approach to setting this up. So on this diagram here, you can see there's an interface that's been implemented by a few of the bus objects, and these objects have been added into the AllJoyn framework, into the bus attachment to be exposed through maybe a game player A, game player B, and then they can be indexed and addressed. And app A and app B can go ahead and discover each other either through the about feature, through the well-known name. That's up to everyone out there who's using AllJoyn to decide what works best for their application. So with that, that kind of closes what I like to describe as the fundamental building block of AllJoyn, really, the discovery, the advertising, and the forming a connection. And so I'd like to, at this time, open it up to some questions that everyone may have, and can go ahead and start to answer those now. And so I'm not looking at the chat window, Wayne. Do we have any?
Yeah, no questions so far. And folks, I had to mute some of you guys because there's some noise. So if you're trying to talk and you feel like we're not hearing, unmute your end.
Wow, if I don't have any questions, then I think I did a good job here.
Hey, Brad, I'm wondering maybe.
Yeah, pretty much.
Go ahead.
I was wondering, when you mentioned earlier that it would take around 40 seconds before you notice a lost connection, is that a variable that can be adjusted, or it's pretty much built in?
So that can be adjusted. Now, there's a method call in the bus attachment called setLinkTimeout. Now, the lowest value can really be 40 seconds. If you need something faster than that, there are ways to decrease that time. You can actually use a default interface that's built into AllJoyn to call a ping method, right, to check if something's there so you can build your own heartbeat. But really that 40 seconds is really around taking a study. AllJoyn was created initially by Qualcomm Innovation Center and then contributed to the Linux Foundation for the AllSeen Alliance. And as such, understanding how to optimize a solution on mobile to conserve better battery, 40 seconds really is around the right amount of time. It's really around the duty cycle of the Wi-Fi driver as far as the beacons when it looks for new signals, so it wakes up and sends information. So if you're idle, right, you can actually send some data when the Wi-Fi does its scan. So it really aligns well as far as performance. It can be changed. You could go into the source code and change it if you chose to, but really 40 seconds is kind of the optimal piece. If you need something faster, it can be there.
All right, nice.
Hey, Brian, there's another question. How frequently does a host send out advertised message?
Yeah, so that happens on two cases. So again, if you remember, there's both a is at and a who has, right? So the who has is kicked off anytime an application first calls the find advertised name. Now, all the devices that receive a who has, they will immediately respond with the is at UDP message. And again, this is over IP transport. So they'll immediately respond, and then they'll reset their timer to 120 seconds. And so when that happens, and I encourage you to go look at the source code because it's really fun to understand and look at, we actually send 3 UDP packets. So because it's a UDP broadcast, packets may be dropped across the network and actually not reach the other side. So we send them, I believe, at I think it's 100 milliseconds apart. So we kind of shotgun approach the system so that it will push UDP packets all the way through. Now, odds are those are not dropped or missed at all, but if one is, then 120 seconds later, that UDP is at packet will be sent out again.
Just another question, Brian. I think the slides mentioned broadcast UDP for advertising. So does it go beyond routers, aka the local network?
Yeah, so it only stays on the local network. Now, I've had IT instances set up special things where they take the wireless broadcast and they rebroadcast that on the wired connection across a subnet. But really, the broadcast stays on the subnet. It doesn't go outside of it unless you're IT or you've set up explicit rules on the router software itself to take that packet and move it up the network chain. So it's all on the local subnet. And again, hopefully you've had a chance to either listen to my colleague Marcello speak or would go and look at a discussion at a high level of AllJoyn, and he also talks about some of the services that we'll have more in-depth training on. But with that, what we have with AllJoyn is really proximity-based communication. So I'm in the same Wi-Fi network as other applications, or I'm at my home on my Wi-Fi network. What is interesting around me that I can interact with, right? I don't need to go out to some gateway through some cloud-based service to communicate with my coffee machine or my child's teddy bear that's right there, right? I can communicate locally over my wireless infrastructure, my home Wi-Fi, and not have to have a hub, right? I just have one Wi-Fi access point, and that can connect all of my devices together that use AllJoyn.
Okay, another question is advertisement and discovery uses UDP broadcast. What if I want to use Bluetooth as the underlying transport between my devices?
Yeah, so with Bluetooth, you would built into it. So there's a couple nuances with Bluetooth. First is that in order to get it to run the way that we would like it to run on Android, for instance, we would need to be integrated in with the operating system. Now, if you look at Bluetooth by itself, it's a hardware trust relationship. I am explicitly granting access when we pair devices, saying that I trust this entity on the other side. Now, I don't know about all of you out there, but if we just met each other at a coffee shop or in a public location, I said, hey, let's play a game. Hey, let's pair our devices together. It's like, whoa, kind of, that's a secure trust relationship. We might not want that. So with the AllJoyn project, we've integrated in with the BlueZ driver, and we have the secure 0-bit flipped. So So that way, Bluetooth, when we use it, is strictly application-to-application communication. We never pair the devices. So if we communicate over AllJoyn over Bluetooth, I can't pull over all your files or push files over to your device. And you also, as part of the discovery process, what we use is EIR and SDP queries. I am sorry, but the meaning of those acronyms are at a loss to me right now. But we use kind of some pre-associated discovery with that, around with the Bluetooth profiles that we have for AllJoyn. Now, on that same note, around the Bluetooth side of things, on Android, in order to have access to the Bluetooth driver to do what we want to do, which is have not just a one-to-one pairing, but a one-to-many and be able to support a scatter net, we need to be integrated with the OS, because talking to the Bluetooth driver requires a privileged access, and an application by itself cannot have that. And then on other platforms, you may not have access to the Bluetooth APIs that are needed. So on iOS, for instance, or other high-level operating systems for mobile, some don't have access to that. So with Bluetooth, really what we're seeing is people building peripherals that they understand and that they want to communicate and leverage. So maybe it is a watch that's paired to your phone over Bluetooth, and the watch knows that it's going to pair to the app, and the watch would be a leaf node. The application on the Android device would be your routing node, so you have something to connect to. And now the watch can be a display or a screen to receive information from other devices, and the mobile device is going to bridge that connection. I've also heard of somebody using a device that they wear on their head as far as with a screen and things, and building a peripheral sensor that goes into their hand so that they can kind of create a magic wand and do all sorts of really interesting things. So what I would say right now, because AllJoyn is not embedded into all of the mobile operating systems, in order to take advantage of Bluetooth, use it in a trusted way, and you can set up a connection between a peripheral that you create that's really going to be that leaf node, and leverage the mobile device in order to bridge your Bluetooth to Wi-Fi interaction. So I hope that gave you all the information you were asking for there.
There's another question about onboarding, and the question is, what platforms support onboarding?
Yeah, so as far as platforms that would support onboarding, and I would encourage you to go to the AllSeen Alliance and look at the onboarding specification. In the specification, any platform that can turn into an access point and that has the ability to run AllJoyn software is a candidate to support the onboarding service framework. Now what happens in this, and again, we'll have a session, I believe, in a few weeks that will focus just on the service framework, so on onboarding, notifications, control panel, but I'll speak to it now. In onboarding, what happens is the device will start up as an access point, and you'll be able to then discover that, and in the spec we recommend that it starts up with either a prefix of AJ underscore, or it could be any prefix, but we recommend that for filtering from the UI standpoint. But what happens is the device that will be onboarding, I'll call that mobile from here on out, and what it will do is it will connect to the device's soft AP. The mobile will then use AllJoyn to discover that it supports the interface of org AllJoyn onboarding. It will then, through that interface, which is a secure interface, so the credentials will be encrypted, right, using AES 128-bit encryption, transmitted over to the other endpoint. Right, sorry, the mobile will encrypt as part of AllJoyn the credentials for the Wi-Fi that you're connecting to, send that over through an AllJoyn bus method call. That will then be unencrypted on the device. It will use that to connect to your access point, and then the mobile device, as part of the spec, we recommend that you change the access point to connect back up to the one that the user inputted. So the process really is about leveraging the discovery piece of AllJoyn and taking into account that the platform has the ability to turn into an access point or a soft AP, right? It goes into a host mode instead of a client mode, and you can configure that.
Brian, I'm just wondering if maybe some folks try to message you privately. I don't know if there's a way for you to try to access your chat. In the meantime, so Robert asked a question, are there any provisions to prevent denial of service style of attacks or jamming the bus?
Give me 1 second here. Oh, yeah, so I see that. I don't see any private messages here from me. So as far as denial of service, so this is where, just like anything, you can try to deny service. Now, someone could write a malicious application that tries to join everything that it finds, right? It discovers everything and joins everything. But there are pieces in place with AllJoyn around security. So you can have secure objects and you would be able to connect to them. You know, if you obviously flood the network and you can't get any traffic through the network, right, that's a problem no matter what software you're using. But as far as built-in mechanisms, you can have as part of your app that session port that I was talking through. So that's one way in which to filter information so you can allow a connection to occur. So like I was using the example of chat, you have a public chat room, right? Maybe you say that that's port 1 if someone tries to connect. And then you use the parts of AllJoyn and you create an interface on which to tell one device to join up to a separate chat. And then you can actually deny service to anyone except for that joiner on that port that you told them to connect to. So it's a lot like right now we're on this conference bridge, but I have the ability to receive private chat messages from all of you, and you could send them my way, and you're not going to be able to block my private chat messages unless this actual network is encumbered and slowed down so much that no traffic can move through it. So there are some ways in there to I guess, get around a denial of service, but just like any system, you're still prone to attacks.
And I would just say the other thing is that since AllJoyn is on the local networks, to some degrees, these devices are a little bit more trusted because they've gained access onto your local network. So it's not like something from the cloud can do a denial of service onto your local network.
Right, that's a great point. So yeah, again, because this is all local communication, right, there is no way to have a cloud piece call into, say, your home and talk to your TV over AllJoyn, right? That's not there right now. It's all for local communication, and that's a very important piece. Yeah, so Robert, you are asking if there was a refrigerator. I believe there was an article. You'd have to look online. I couldn't speak to that, but I think I heard something as well along that line. So Alfred here is asking me a message here. What is the best way to reach some of us for questions? Really the best way to get in touch with us, and I know it's there on the AllSeen Alliance page. Under the developer section, there's a forums. I'm one of the commenters there, and I've provided answers. We have other members from the team that have provided answers. So that's kind of one of the ways in which you can get in touch with us and start to ask your questions and get some feedback. And if you're stuck and have other questions, if you just want to have a concept discussion, the forum's a great place. If you just have an idea, I want 2 applications in which to exchange a chat message. We can talk you through how to use those examples that are part of the SDK and point you and guide you in how to architect and use the AllJoyn APIs to create your vision. So Robert's kind of commenting here that, of course, local traffic is no guarantee of security. That's entirely correct. So if you're on the home network, you of course have access and kind of that level of trust. But again, we do have secure interfaces with AllJoyn, and we can encrypt that data that travels between it, and you can deny access. So I believe there is a discussion for a security work group that will be coming about. And so, Robert, I would really encourage you to, through the Alliance, to start to send emails out over the Alliance mailing lists and try to get a seat on that. It sounds like you know a thing or two about security, or would like to have some input through the Alliance as a community member to participate. Okay. We've got a few people on here still. You know, I've got some time here, so I'm more than capable to stay on and answer any questions. And again, if you need to get in touch with us or ask kind of an AllJoyn expert, the forums is a really great way to get involved. And we've started to see, myself, I've seen an uptake of other community members that have just started to use AllJoyn and have actually been helping each other out. So it's a really fantastic thing to watch this open source project grow to what it is right now. So we'll give it a few more minutes here. You know, don't be shy. Ask your questions. It's, you know, with AllJoyn, it's some of the terms can kind of get in the way of actually the simplicity of the APIs and the use of things. You know, really a well-known name. It sounds, you know, kind of interesting at first and a little kind of what is that? I don't know what a well-known name is, but hopefully today you start to have a better understanding of really the fundamentals. You want to find something, you connect to it, and then you use an interface, and that interface is the set of methods. And it's really, when you boil it down, it's quite simple. And I would encourage everyone to just download the SDK on whatever platform you're comfortable with and start running the samples and looking at the code, and just make a modification and have the joy of, hey, I just changed this method here, and now I can pass over a string. Or I can do this, and I can do that, and it's really easy to build on top of the samples. So there was a message asking, is it possible to receive a lost advertised name callback without a session lost? And this is a very good question. It is entirely possible because the advertising discovery is based off UDP traffic. It is possible to be in a session with a device and then receive a lost advertised name because the UDP packet didn't make it over. So when you build your application and you start to use AllJoyn, once you're in a session, the most reliable way, and really the most reliable way, is to use the session listener to have it tell you about other applications that have connected, or when you've actually lost connection. And there's one interesting thing that you'll find with session lost when you create a multi-point session. So let's assume again, if you can remember, I had the three devices. I had A, B, and C. And in my example, A was the one that was hosting the session. And what happened in that is on IP, both B and C connected. Now, when they connected, they joined in a multi-point session. What happens, because they all become peers, if A walks away and leaves proximity, so if we were all together and someone had to go and they jumped on a bus and left, right? What would happen is that B and C would still be connected. They wouldn't end up dropping off, and they could still communicate, but no one else could join in the session. So in a multi-point session, session lost will not execute until there is until there is only one person left in the group. So there's a question here, do we have a dbus monitor kind of thing to see the traffic as it goes across the bus? So this is a great question. So one of the pieces that is AllJoyn in a closed room environment was written from the dbus spec in the ground up, but it's really grown from dbus because it goes off device, security is in there, we have a topology manager, we have a Wi-Fi transport, we have a Bluetooth transport, Wi-Fi direct is in there, we now have a serial line protocol. So it's really grown more than dbus, but at its core it's built around that piece. There is a application that is, I believe, it should have been open source by now. I think it's what is it, Wayne? It's Defeat. There's an application that you can use to browse the network and see what's going on. There's also a plugin for Wireshark, so you can look at the network traffic and see the UDP packets as they go across. So these are two tools, and please ask this question on the forums, and we'll get you the accurate information so that you can download this, and you'll be able to see what's happening and be able to find the interfaces and see what's going on. So there's another question here, is if a router node has two transports, one is a Wi-Fi leaf and the other is a Bluetooth node, or basically a leaf, can the two communicate? And yes, they absolutely can in the topology. So if everything speaks AllJoyn, it doesn't matter what transport you're on, as long as there is some way to route messages to the endpoint. So I like to use the example, I have a Bluetooth sensor, right? And it may have some light bulbs on, light LEDs on it or something. I have my mobile device, which has Bluetooth and Wi-Fi, and then I have my laptop, which has just Wi-Fi. I can write an app on my laptop that can communicate with this sensor and get readings from this sensor. That's entirely possible on AllJoyn, and it uses that routing node to its absolute fullest to route the messages over between the two endpoints. So this is how it manages that mixed topology. Looking through, there's another question here on the routing nodes, which is, does the routing node know the status of a leaf node? So if a leaf node goes offline, the answer to that is yes, it does have awareness, because what happens with the routing node and the leaf node is the leaf node offloads all the kind of more routing specific and some processing onto the routing node. So for instance, when the leaf node wants to advertise, it doesn't do it directly. It asks the routing node to advertise on its behalf. And this does a few things. One, it allows those leaf nodes to leverage the thin client architecture and be on an MCU that has a small battery and can go into low power mode, right? And then they can wake up and ask the routing node for messages. And if the leaf node goes away, because there is a session that's established between the leaf node and the routing node has that awareness, and it can send out a lost advertised name on the leaf node's behalf, or it can send out the session loss signal to everything else, right, so that they know that it's no longer connected. So that's the benefit and the design of the leaf node and routing nodes on building that graph. So I hope that answers your question, June. Thank you as well. So I'll give it 3 more minutes here, and then I will say thank you now for everyone for attending. This has been a pleasure to teach you about AllJoyn. It's a great thing to see this growing and becoming really the glue at which all of the things that we build can communicate together and interoperate. So we've got it looks like probably this will be our last question unless anything else comes in. So there's a question wondering if Wi-Fi Direct will be allowed on Android devices. So right now Wi-Fi Direct is a growing and it's a standard really kind of at its infancy, and we're seeing across various different devices some different implementations of the spec, right? Which is an important piece to understand right now, because Wi-Fi Direct is a spec, and AllJoyn is an implementation and basically a de facto spec. So we have AllJoyn for many different platforms and many different operating systems, so that there cannot be differences in the use and for interoperability. But with Wi-Fi Direct, what you can do is you can manually set up a Wi-Fi Direct connection between devices, and you'll be able to use AllJoyn over that IP transport. The other piece around Wi-Fi Direct is there is software there in the AllJoyn stack. However, because on certain devices, again, there's some nuances. For instance, an Android device communicating with a Windows 8 or Windows RT device, there's some interoperability differences right there. So it's really coming through as far as you're open to taking the AllJoyn source code from the AllSeen Alliance Git repository, building it with the flag to turn on Wi-Fi Direct support, and then trying it out on your devices. So it is software that is there. It just has to be more widely adopted and implemented exactly to the spec. So this will be the very last question that I'll take right here. On remote access, is there functionality for a wide area network connectivity through, say, a firewall, a DNS, or a NP firewall connection? So really right now, AllJoyn's focus is solving the proximity problem. Now, through the Alliance, you'll probably see proposals on how to build kind of this gateway remote access type of communication. And I would encourage anyone on the line to try to participate and be involved in the Alliance discussions through the AllSeen Alliance with the working groups, and talk through kind of what your thoughts are on how to bridge a remote access. But currently right now, there is not that ability. We do, however, have a transport that's called our ICE transport, and this is to solve a problem that in the early stages, developers would build an application, they build this great game, and they go to a public place and they meet up with their friend and they want to show it to them. They connect up to the coffee shop network or a public network, and they find out, hey, my app doesn't work. Why is this? It's because the configuration at most public access points has what's called wireless isolation, which limits the ability for peer-to-peer interaction. And they also have multicast packet routing turned off. So even if I can discover the IP addresses, I can't route any broadcast packages to them. So our ICE transport is a way to bridge that gap and allow, by understanding what the BSS ID is on an access point, we can determine we're still in proximity, and we can set up a proximity-based connection. Now again, you have to be on the same network, but we do have a piece that allows you to have a solution in that environment, but it does not allow for remote access. So with that, I'm going to say thank you, everyone, for signing on, and if you could also attend next week's discussion, where we'll dive in on actually how you build out the APIs that you expose over AllJoyn, what it means to build an interface, how you leverage a bus signal and a bus method to build out the functionality that you care for. So we'll dive into that next time as part of the second half of this core training. So thank you very much.